Yeah, I thought I'd post up another video as it relates to the Cleveland oiling subject, and a recent experience sort of prompted it. But we'll get right back to basics for a start. As I'm sure you all know, that the oiling gallery for lifters in the Cleveland runs along the side of the lifter bores, so it intersects. Does so in the 385 series as well, but in a FE and Windsor and Chevs, the oil passage is actually on centre, so keep that in mind. We'll start by looking at like a solid roller lifter. As I'm sure you all know, solid roller lifters have no hardware in them as far as oil metering goes. They are just a one-piece solid body. So the only means of actually controlling oil flow up the push rod is by the position of the oiling hole. This is a comp Cleveland solid roller, and you'll notice the oiling hole, because the lifter gallery is running down this side, the lifter hole is 90 degrees to the gallery. Whereas, turn over, this is a Windsor, you'll notice that the oiling hole is either directly in line with the oil gallery itself, or sometimes it's on this side here. What that means is if you use a, I'll pick that up again, if you use a Windsor lifter in a Cleveland application, if the oil hole is drilled 180 degrees away from the gallery, you'll have little to no oil flow up the push rod. If it's on centre with the gallery, the chances of flooding the top end with oil are very high. Now the hole, the oil transfer hole if you like, is around 110 thou, and in the instance we had the oiling hole that was only drilled on this side, and we had no oiling getting up to the top end at all. The manufacturer doesn't matter, but the manufacturer suggested that we put a small slit in there to allow oil flow up to the push rod, and a video was supplied of a guy doing that. Unfortunately it supplied far too much oil up there. We tried putting a plug in there with a 40 thou hole. That made little to no difference whatsoever, and in the finish we had to plug that hole with, and leaving it proud this time, so we basically finished it off flush with the diameter of the lifter, and what that did was cut off that little slit there that we'd put in there. After that, the only means of actually controlling the oil flow was by putting virtually a hairline scratch in there, and I mean extremely small. So small that it took like several hours to go through the lifters and do them all, and we were statically testing them with driving the oil pump with electric drill, so we could get the oil flow about right compared with a comp lifter. It was successful in the finish. I'm sure there's plenty of you asking, well, what about a flat tappet lifter? They rotate along with the oil feed hole, of course, and in those cases, and it doesn't matter whether it's hydraulic or a solid, they have their own internal metering system, either via plate or via valve in there, that controls the amount of oil that's going up the push rod. But that is by no means the beginning of the end of it, because the actual volume that gets transferred up the push rod through various different types of lifters can vary considerably. And I'll give you an example of this. And this information came from Paul Dilley in Queensland in Australia. He did some quite extensive testing with flat tappet, solid flat tappet lifters, and the volume of oil that was getting delivered up the push rod during the same sort of static test. He tried some Howard lifters, and they were supplying 40 cc's per 10 seconds per side, or per bank if you like. He then went to some Speed Pro lifters. They were supplying 64 cc's in 10 seconds per side. So basically double what the Howards were supplying. He then tried some Trend tool steel lifters, and I believe that they control their oil flow with different size holes in the push rod cup. But with a 14 thou hole in the push rod cup, they were delivering 80 cc's in 10 seconds, which of course is double what the Howards were doing. And the same lifters with a 30 thou hole were delivering 320 cc's per 10 seconds. So that is an 800% or 8 times what the Howards lifters were delivering. So it's very easy to see how people can get themselves into trouble and end up filling up rocker covers full of oil if they're using a badly metered lifter. Just a few more comments that I'd like to throw in. You do hear people talking that lifter bushing is a way to control oil to the top end, and while lifter bushing does have its place, I highly doubt whether it's a valid method of controlling oil to the top end, especially when you consider that a 14 thou hole in a Trend lifter is still delivering twice what a normal well metered hydraulic lift, flat tappet lifter is. So you'll also run across comments of people who claim that the Cleveland was designed as a high revving engine, and as such they were designed to either A, run a lot of oil up to the top end to keep valve springs cool, or B, run a small oil bath actually in the rocker covers, once again to keep the valve springs cool. I don't really buy either of those options. Number one, if they were designed to run in an oil bath, the capacity of the sump would need to be at least double, and I'm talking more like 10 or 12 litres to guarantee oil supply to the pump when the rocker covers are getting flooded with oil. And I can state that as a fact because when we modified those lifters that I was mentioned with the small slit, there was that much oil getting pumped up there, even at 1500 revs and a 7 litre oil pan. it drained it within 20 seconds. Regarding a lot of oil getting pumped up there, once again to cool the valve springs, I don't really buy that one either. I think if that was the intention of the designers, they would have made a much better effort in the oil drain backs, especially at the front of the block and head, because it's not great, let's face it. The rear passage is pretty good though, despite that. So I don't really buy that one either. I'll leave it at that. It's basically beware of